Good morning, fellow programmers. Thanks for joining me. I'm to pay. And welcome to Let's Learn C++. Feel free to use the skip ahead feature on the right-hand side to jump to any specific sections or examples. Make sure you have annotations turned on so you can see the updates I make to these videos. I'll be using Visual Studio Community Edition, which you can download from visualstudio.com. However, you can follow along with whatever you like. Today's focus will be the first of a three-part series on functions. This builds heavily on previous lessons, so check out those if you are unfamiliar with a topic. If this is your first programming language, I'd strongly recommend you check out my Let's Learn Python series, which teaches you the fundamentals of programming. All you need are the basics and object-oriented programming series. I don't know how to say that. Link to the right, and you will be well prepared for this C++ series. Alright, functions. What is a function? A function is a shin, could be a man's or a woman's, shin that is infected to such a degree that it stinks. It is smelly. It is funky. It is a function. Okay, terrible joke. C++ Core Guidelines, Part F2, says a function performs a specific action or change to the computer's state. And I think that is a good description of a function. So I've pasted in here a simple function example. We have our same old code of including the IO stream and including the string, as well as using namespace standard, which is a bad practice. I will explain in a later tutorial when we cover namespaces. But for now, just know it should be generally avoided when you get into a professional line of programming. And then here, right here, void print underscore ham with open close parentheses, and then just cout ham, is our function, our very own function. Oh, we're parents. We have our own function. How cute. All right, so let's go over the parts that make up a function. The very first part is the return type that you're going to be outputting from the function. Then is the identifier for the function, or the name of the function. After that is open close parentheses, where you can pass in parameters or arguments that are needed to call the function. And then you enclose a block of code following that with curly braces that will be the body of your function. And that's it. It's pretty similar to how Python is, but the exception is you actually have to be explicit and declare what is going to be output from your function before it's actually defined. Down below, we have the actual call to the function itself by just saying, hey, print ham, open close parentheses, and that's it. So if we run it, we will see that the program actually does just that. It prints out ham. And then we can press enter to satisfy that get line condition, and the program will close out. Perfect. And that's all there is to making functions. Thank you so much for joining. I'm just kidding. There's a lot more into functions that we're going to dive into. And the first and most important thing is the naming of the function. The C++ core guidelines have a lot to say about naming, and in particular, naming functions. NL1 says, no need to create comments for what is clear in code, especially in well-named functions. In the past, you may have been creating comments for every single line of code, and just as a rule of thumb, I want to say that there's no need because a well-named function will be descriptive enough of what's going on in the program. NL.10 says, avoid camel casing, instead use underscores and capitalization. This is more of a preference rather than a rule. I personally like this recommendation because I find that it is much easier to read this function than it is to read this one. That underscore makes it clear that there's two different words rather than a bunch of letters strung together. When naming your function, you should follow the established rule set of your company if they have one already in place. So everything I'm telling you right now, you can throw out the door because what your bosses dictate overrides anything I'm going to teach you. So yeah, but for your own programs, I'd recommend this naming method. NL8 says have a consistent naming style. This is paramount. So if you're working on a multi-project, multi-sequence, or multi-shot pipeline, then you may want to do like project underscore sequence underscore shot underscore and then like asset if you so desire. This is an example for how you would have a specific naming convention style. So no matter what it is, throughout your program and throughout your programming career, try to have a consistent naming style. It's really up to you to determine what that is though. And only practice will teach you what it is. In fact, I'd strongly recommend looking over other people's codes to see what they have chosen for naming conventions. Next, we're going to talk about input and output for functions. Input is passed in through parameters or arguments, and output is produced in functions through returning or through changing data from a reference or pointer value. The stuff you pass into parentheses next to a function is called a parameter when you're defining a function. And it's called an argument when you're calling that function. So at the definition of the function, we're creating parameters. At the call of the function, we're creating arguments. An argument is also what we call a loud screaming discussion that I like to have with my girlfriend. That's a terrible joke, but true. Argument options and return types are none, or you can have it empty. Char, int, string, and auto are all parameter types you could pass in. Arrays, references, pointers, any number of things. And when creating references as a parameter, it is extremely useful, as we'll discover here in a few minutes, because it doesn't actually make a copy in the function. Instead, it will pass in the value itself. You can also pass in templates, item collections from the STL, like vectors, queues, dictionaries, and more. And you can even pass out cin and cout, custom classes, anything really. So it's very similar to how we had in Python. All right, so let's go over some input examples for functions. I'm going to go ahead and paste in a ton of code here, and we're going to go through it little by little. And I'm going to go ahead and minimize these real quick. All right, so lines 5 through 7 here, we have print words, which is just a simple print function. And we're passing in a string as a parameter, and it's going to be called A. And then we just output that variable. Something to note is that this is actually a copy of the original variable. If we were to try to change this value A, it would not affect the original value or variable we had passed in as an argument. And we'll see more about that in just a minute. Next, I'm going to look at the add one. Now, this parameter is taking in a pointer to an int rather than making a copy as we did up above. So what's going to happen when we try to increase that value by 1? Well, you may think to do it this second way as the way you want to do it. You do just the pointer to the value at I, and then you just do plus plus. That should work, right? Let's go ahead and run the program to see what it actually does. And we're going to go ahead and stop the program at add 1 right here. Actually, let's stop it right below so it actually prints out. Okay, so we've successfully printed the words ham sandwich. Then we're outputting 6. What's going on here? We've created this variable called 5. Then we're passing it in by its address. Then up above right here with this star I, we are trying to say, hey, get the value at this, and we want to increment the value at I by 1. The second one says something entirely different. What it's saying is go ahead and get the pointer to the very next item in the array. The thing is that we're not passing in an array, so it's going to jump to a weird garbage value in memory. And so if I uncomment this next line out, something very interesting is going to happen. Now when I run the code, we're still getting 6 as being output. Why is that? Because we only incremented the value of the original address by 1. Then we switched the address and incremented the following address by 1, which wasn't the original value. So essentially, some random address in memory just changed value, and we don't know what it is, and we don't know how we changed it. So whatever we did, we just screwed up in memory. So yeah, don't do that. Know that using the parentheses in combination with the star and the variable name is how you're going to get the value at that address. And then you can use the plus plus afterwards to actually increment its value. So yeah, that's how that works. Very tricky, very cool. All right, let's go ahead and stop the program there. We're gonna go collapse that function. Now let's move on to add to. Now what's going on here? Now, instead of passing in by a pointer to an int, what we're actually doing is passing in by a reference to j. And then we're just saying, hey, go ahead and add to this, okay? And here we have the actual call to it down below. And what we'd expect to see is it output 8, because A is not being copied into the function, it's actually passing in the raw address of it. So what's happening is X is being passed into, and instead of creating a copy in this function, it's actually using the object, the original object itself. And so we can manipulate its values because of that ampersand or that reference symbol. Cool. So it's not making a copy. All right, let's go ahead and stop the function right there and go ahead and run it. And we will see that indeed it works just like that. So now X has been changed from a value of 6 to a value of 8. Very cool. All right, what's going on in our next function? It says increment array. What are the parameters? Here we're going to pass in an array, and we're passing it in by a pointer to the array. And the second parameter is the size of the array. I put in this size with a default value of 5. In this specific instance, we would never want to have a default value of 5. We would want the user to always have to input this. But I wanted to show you this is how you are going to create default values. It's just like in Python. You just set the variable equal to whatever the default value you want is. Only difference from Python is that you actually have to declare its type right here. That's it. Then I'm going to go ahead and iterate through the size of the array, and I'm going to increment each individual value of the array by 1. Then I'm going to access each individual item of the array with the square brackets and I, and then increment the value at that location. Beautiful. So next in line 36, we have our actual declaration of our array, and it just says it just has a series of values of 1, 2, 3, 4.5, and 77.7. Then we pass it in by its name. Remember that its name is actually a pointer itself, so we don't have to do anything special there. And then we pass in the size of the array, which is 5, because there are 5 numbers in this array. Pass it in the function, and now we're going to go ahead and output afterwards to see if our function worked correctly. Let's go ahead and run that, and we're going to go ahead and step over there. There we go. Stepping over, stepping over, stepping over, and here we go. Notice that it does increase all of the values. So 8 was the X value, and then here is our array values, which are 2, 3, 4, 5.5, and 78.7. So all of our values have increased by 1. Perfect. So passing in an array into our function worked beautifully when it was a pointer and we passed in the size with it. Beautiful. Note that you need to know the size of the original array. You can't just grab a size of function or something to grab the size of the array. You have to know it when you declare it and store it in some variable if you're going to be using that elsewhere. This is also why arrays suck, because they don't have the size built into them. Meanwhile, in the standard template library, or the STL, you have things like vectors, dictionaries, lists, queues, stacks, any number of item collections, and all you got to do is call a simple function like size that will grab the size of them for you. So this is why arrays suck, is you actually have to keep track of everything manually. But it is very memory efficient. So if you're looking for efficiency versus convenience, then maybe go array. And my goal is to, at some point in the future, show you how each of the STL template library items were actually constructed to some degree. I'm not going to actually do it to the depth that they do it, but I will create a simplified version so you can understand what's going on underneath the hood. But this is not going to be until we get to the advanced tutorials, which is way down the road. Okay, so that's it for this input demo. Now let's go through a bunch of output examples. I'm going to paste in some more code here, and feel free to copy it or follow along with me. So now we're going to be looking at ways to output with these examples. So the very first function I have created is called return1. You call it, and it just returns 1. Oh my gosh, it doesn't get any simpler than that. Next, I have a function called avoid this. Now, what the heck is going on in this function? Why is it in all caps? You said we should actually do it like lowercase and then have capitalization on the first of every word. That is because I do want you to avoid this. Don't ever do this, ever. Like, well, what the hell am I saying this for? Look at what's going on inside the function. First, we create this variable, and then we're returning a reference to that variable, and we're going to be outputting an int pointer. But Trevor, doesn't that mean that this local variable will be destroyed once the function ends? Yes, it does. So it will be destroyed. It will return a garbage value, which will result in problems for your program. So don't ever do this. ever. And, well, we'll actually cover how to dynamically create stuff on the fly in a much later tutorial after we cover classes, because it is a somewhat tricky subject. Then I have this other function that's called avoid this too. What's going on in here? I'm going to be returning an int pointer. And here I actually create an int pointer, have it equal to a value that says new right here. I don't know if you can see it. It says new int, and it's creating an int array of 5. And then it's returning it. So why is this bad? This seems all right. New is a keyword that we haven't talked about yet, and we won't be talking about for some time, but it's basically to create dynamically allocated memory. So we can create new stuff on the fly, and it won't actually be destroyed when this function ends. It'll work just fine. So what's so bad about it? I'm telling you to avoid this because what happens if this pointer, wherever it's stored in, decides to point to somewhere else? This stuff is still going to be in memory somewhere. And that is a resulting memory leak, which is bad. There are ways to get around this, however, and I will be showing you again in a later tutorial. I am just full of teases. I am worse than a Marvel movie. Instead, what we would want to create is a shared pointer or a unique pointer, or have an owner being returned. And again, I'll cover all that stuff in another tutorial. Next, we have avoid this also. And this is pretty much the same thing as I've been iterating up above. It's creating a variable, it's returning that variable, and we're just saying, hey, return a reference to that variable. But again, C is going to be destroyed. It's going to return some garbage value. So don't do these things. Don't do them. So then, Trevor, how do we return variables? I'm going to say this, and it's going to sound kind of strange, but for now, don't worry about returning arrays, pointers, or references. Just don't bother doing it. If you're going to return something, just return the regular value. Again, I will instruct you how to do all these things in a later tutorial, but there is reason behind all this. And you can look at section I.11 for more information on the C++ core guidelines. All right, now we're going to go ahead and try out some of these functions to see what they do. Lines 22 through 29. Let's go ahead and run it. Now what is being done here? First, we're going to go ahead and create some pointers x, y, and we're just going to create an int called z. So first x is set to equal to avoid this. And this was where we had created a local variable and then returned a reference to that local variable. Now what happens here? Well, it actually doesn't destroy that local variable and just lets that memory of 2 sit in memory. Well, that's weird. I would have thought something else had happened to that value of 2. Oh well. Let's continue, see what else is going on. So then we have y equal to the function call of avoid this too. And what's it outputting? It's outputting some weird garbage value, even though we set all of these ints up. They should have defaulted to 0 or something, right? Nope, just gonna have some random garbage value. So z is gonna be equal to avoid this also. And when we output z, it's having a value of 4. Huh, that's really strange. Because avoid this also is just creating that value of 4, and it's being destroyed at the end of the function. So how are we getting this value 4? Well, what's going on is it's just sticking in memory because no values have overridden it. That's the problem with trying to return local values, is that sometimes they'll stick in memory and then later on they'll be overwritten. Now how are they going to be overwritten? Well, watch right here. We have a character array being created equal to ham sandwich. Then we have z being set to 15. So what is x? X is being set to some random value that's being changed in memory. Y has remained unchanged with some garbage value, but z has actually changed its value successfully to 15 because z is just a regular non-pointer variable. So again, avoid these things, please, please, please. All right, and we'll go ahead and press enter to exit the program. Yeah, so a few other things I want to bring up from the C++ core guidelines, and this is going to sound like me just spewing knowledge into your brain, and these are going to be extremely hard to grasp, but in time they will make sense. NL18 says C++ style decorator layout. Address of operators should be left next to its type. So in other words, put ampersands and star symbols immediately next to the data type of the variable you are declaring, rather than immediately next to the variable you're naming. Sounds weird, but needs to be said. I4 says make parameters strongly typed, and NL25 says don't use void as an argument type. And this is to say that void star shouldn't be used as an argument type ever. Instead, try to be explicit and strongly type your arguments so that it is clear what they're passing in. I11 says never transfer ownership by a raw pointer. Again, we'll cover this in a later tutorial where we're going to be using owner, shared pointers, unique pointers, and all that stuff. I-23 says keep the number of arguments low. This is for clarity and so you don't have extremely long function calls. I-24 says never place unrelated types args next to each other. And this is to avoid confusion. All right, so the body of a function. The body of the function is within the curly braces. Guideline F.3 says keep functions short and simple. They recommend having it between 1 and 5 lines of code for any given function. I'd say that's a little extreme and it should just generally be less than 10 lines of code. The rule of thumb is it should all be able to fit on screen for a function. Otherwise, you should break it up into smaller functions. But T-Pain, I can't. Yes, you can. I believe in you. Identify chunks of code that you are repeating and make a function for a particular task. If it's still too long, break it up more. And that is it. Thank you guys so much for watching. Great job keeping up. Definitely try these coding challenges shown here and the debug challenges linked below in the description. You are a brilliant programmer and I'm sure you can do it if you set your mind to it. I will be posting solutions for all these problems after groups of tutorials, but I really want you to develop your own skills and solutions. There's often many correct answers. Please leave me a comment below if this helped you at all, and also check out the comments below if you're having any problems. Lastly, do me a huge favor and please subscribe to my channel. It would really mean a lot to me. Hit that like button to show some love or support me on Patreon. Thank you so much for your support and keep the dream alive.